So, have you ever wondered how computers communicate with each other? That's what I'm going to show you today. Right. So, let's say we have two computers here. Right. This could be, you know, any computers. Let's say in your house you have a desktop or a laptop in your room, and let's say you have another computer in your in your office. So, in order to, let's say, transfer files, if you want to transfer file from this computer to this computer, right? Or if you want to do anything, if you want to send a message from this computer to this computer, you need to have a connection between those two computers. So there are two ways you can do that. One is using a Ethernet cable, or you can use it wirelessly. But let's first focus on internet, like Ethernet cable, because mostly everything is connected. Like you know, if you look at the internet from a bigger perspective, you'll see that everything is connected via fiber cables, and they have the same concept. So let's say we have two computers here, and since these are the same computers, we'll use crossover cable. Um, or can we just select the lightning cable and then icon and then just get them connected, and it will auto select the proper cable. Now we have the computers, right, connected to each other using a wire. So how would they transfer a file now? Well, if you were to send a file, it wouldn't know where to go. Like it needs an address, or it needs a way to communicate to find a destination, right? So let's say PC0, we'll need to add IP address. So we'll go to the fast Ethernet, which is a port. So let me show you where that is. So if, on your computer, you'll have a port that looks like this, right? So you connect, the cable is connected to this port right here. If I were to show you that in a physical view, let's see. Where that is. Well, this is a rack, but let me find the go home. Okay, unfortunately, you know, the all it's showing is this. It's not showing the actual computer, like how it's connected, but that's fine. Let's go to there is a way to find but it's fine. So the port I just showed you, it connects to that computer, and same thing on this computer, that the other end of the cable connects to this computer on PC1. So on PC0, we have to add like an address, right? So for that interface, like the port, it's called an interface. So you can add an IP address. It just needs a number. If you watch my subnetting video, you'll see like what IP addresses are. But basically, um, in a general term, you can have any number between 1 to 255. Oh, 254. Because if you were to do like 255.255.255 dot, say it says invalid IP address because you can't have 255. That's broadcast. So you can do 254 though. 254.254.1. No, sorry, 254. Well, no, you can't have that either. I guess. So it's smart enough to know that these addresses are reserved. Yeah. But let's use an IP address on 1.1.1.1. Well, so usually you would do .1, like the last bit for default gateway, and what that is basically a way for the computer to get off your network. So if it doesn't know where to go, it will use the default gateway to go to a different network. So let's keep this one as 2, and let's give it a class C IP address. So it will be 255.255.255.0. That's a class C network. This one is not like 1.1. Is not class C. It's class A IP address. But it doesn't matter for now. For testing, it's fine. Even in real world, it's fine, but it's not a good practice. So because if you want like actual class C IP address would be like you can have 192.168.1.2, and that's what you'd find in your house too. Like if you open up your if you open up your computer and you go to command prompt on Windows, right, or Mac OS, and type in ipconfig on Windows or ifconfig on Mac OS, you'll see that your computer has an IP address that probably starts with 192.168. That the last two might be different. Most likely it'll be one dot, and the last digit, and you'll see the subnet mask is 255.255.255.0, because that's how mostly all the like home network would be subnet it has. So now that this computer has this IP address, we're gonna do something real cool. Watch. So I'm going to do ping. Basically, ping means okay, I want to see the connectivity between the other computer. So let's say I'm going to ping 192.168.1. I'm gonna give the PC1 IP address of .3. Well, let me do something better. Ping. If I do /t, it will continuously ping, because otherwise it would stop pinging after 4 tries. Now that we have this here, I'm gonna keep that here. So that's PC0, as you can see. And I'm going to create let me see if I can open both of them. Okay, so you have PC0 here, the left one. This one has .1.2 IP address right here. So I'm gonna give this one watch PC0, right? On PC1, I'm going to give it 192.168.1. Ready? Watch. As soon as I give it 3, it's going to start pinging. Watch. Look at that. So as you can see in PC0, it's able to now talk to it. Like it says reply from the .3 IP address, which is PC1. So it says reply from PC1, and like how long it took to get the reply. And it says request timeout. Before it used to say request timeout, since this one doesn't have IP address. Now I'll show you something else, right? Let's say if I were to change the last bit in here to, let's say 0, it will still work. Why? Because it's still in the same network, and you'll understand why that's the case. But if I were to change the last bit to something that's out of range, then it will stop pinging. So for example, let's say this is 255. Let's do I entered the wrong subnet, but let's say that wouldn't work, because then I'll have to change the IP address too. But as you can see, the request timed out because I changed the last bit. It wasn't valid. But again, like if it was on a different network, it would stop working. So right now, as you can see, it's still pinging fine. Let's change this to let's do 128. 128, I think that might still ping because it's still in the first octet. I mean, sorry, like the first, still in the range. But if I were to change this to 128 plus 192, it still works. It's good. But if I were to change this bit, then it wouldn't work. So let's try that one. Let's make this one 0. But if I were to change this one to 128, or it will still work for some reason because it is in the same octet. I see. Okay. How can I not make this work? This is on all three has to match. 128, 192. That works because it's strange. Let me open up Notepad and just do the calculation so you can see it too. So 128, 64, 32, 16, 8, 4, 2, 1, right? And then we have, so this is dot 192, right? So we have 192 has to match, 160 has to match, and then we have 192, so that's the range of 64, because that's what gives you, so this would be basically, you'll have 0 dot 0, and then you'll have dot 64 dot 128. So if we do dot 64 here, let's see what happens. Alright, I don't know what I'm doing now. Oh wait, because did I add 2 0 here? 2 dots here? Invalid. Oh, because yeah, you can't have like, okay, so that's a rookie mistake. So the subnet mask, you can't have just dot 64, you'll have to, it will be increment of 128, and then you can start with 128, which is valid, but you can't have 129. Oh. You can't have something like this, but you can, so 255, 255, well, yeah, 128, and then 128 plus 64 is 192, so you can have this, and that's valid, right? You can also have this, and that just changes the IP address, and that would now work in the ping request. It would now work. Sorry, it would work. Alright, this, yeah, it would work because it's still in the same network, like the IP address. This is still same as the other one, like 192.168.1.1, and the only requirement for the other computer is that it needs to be on the first 3 digits has to match. That's it. If I were to change this one to 2, and then if I were to ping this, it will stop pinging, of course, right? Because it's trying to ping 1.3. But if I were to ping 192.168.2.3, it wouldn't ping.